It takes place at the boundary, right? Yes or no? Gianna and Harshit, clear it? At least
Yes, sir.
respond.
Yes, sir.
If it's possible, so if it's possible that both of you can switch on the camera, bacho, is it possible? So that we can have a good interactive class. Harshit and Gianna, please let me know, bacho. What happened? At least answer yes or no. Yeah,
No,
Gianna.
sir.
अच्छा अच्छा ठीक है हर्षित. Verification of history. Yeah. And what is basically what is the denser medium and what is a rarer medium in this basically in the refraction concept? Tell me, please, Ashit and Gianna. What do you mean by rarer and denser with respect to the refraction point?
Sir, rare means that it is the like a medium in which the speed of light is more. It is
Mhm,
known as the real medium,
mhm.
and the tensor is the less. If the speed of light is less in this medium.
Yeah, correct. Gianna, what about you, dear? Gianna, are you there?
Yes, sir.
Nabila, assalamu alaikum. How are you?
Wonderful, sir. Thanks, sir.
Yeah, that's good. Just a moment. Okay, so I was just waiting for you. Just a second.
I'm sorry, sir.
No, no, no worries. चलो कोई बात नहीं. Okay, so Nabila, I was just discussing the things that we have done in the last class, right? So I was just asking what is refraction in optically denser and rarer medium, right? With in regards of refraction. Okay, so now it's time to understand the things, some different topics based on the refraction. Just allow me a moment. So all of you are revising or not? Yes, please tell me.
Yes, sir.
Okay. Just a moment. Okay, so before, yeah, yes, Nabila, you were saying something? अच्छा हर्षित, हाँ बोलो.
सर मैं एक मिनट जरा 5 मिनट होल्ड पे, मुझे कहीं जाने तो मैं बस 5 मिनट के अंदर आ रहा
ठीक
हूँ सर.
ठीक, ओके ठीक है, आ जाओ. Okay, no
ओके
worries.
थैंक्स.
Okay, so let's understand the effects of refraction. Like, what are the different effects of refraction? Like, how we can observe this thing in the real life, right? So, first point is, Bicho, okay, effects of refraction. First, refraction basically is that, suppose that if you place an object in the water, it appears to be a little bit raised. Like, it doesn't seem that it's very in depth. It seems that it is very upright, right? Yes or no? It's raised, yes or no?
Yes, sir.
So that is also that this phenomena is due to the refraction. Okay, this you can say observation. Okay, an object here appears to be raised. Okay. Sometimes suppose that you have taken a glass of water, and if you basically put basically the you can say place the pencil into the water, you will see that the pencil will be not directly touching the you can say bottom of the glass, but it will be touching the side of the glass. It will assume basically it appears like that. Yes or no? Have you seen that thing, Micho?
Yes, sir.
So basically, if you take a glass and put the pencil inside that, the pencil will not be straight. It will be a little bit bended, upright. Yes or no? Have you seen that thing?
Yes, sir.
Okay. Yeah. So that is also the you can say observation of refraction. Okay. Second is stick. Stick a pencil in it, held obliquely. Partly immersed in water. Appears to be bent.
Sir, I'm back. So
Okay, okay, Harshit. Okay, that's very good, Bachir. Thank you for updating me. Okay. Water surface. Okay, so you can say second, third point can be like this. You must have seen that if you observe that whenever the a swimming pool is filled with water, you will observe that in the that swimming pool will not be will not look that much deep than it is actually. It will seem like it's just you can say 1 or 2 meter deep, but in actually it can be 7 to 8 meter deep. This is also due to the refraction, right?
Yes.
Yeah. So this is the last point. Okay. A pool of water appears to be less deep than it actually is. Yeah. So these are some you can say effects of refraction of light, right?
Yes, sir.
Yeah. And one of the most common example of refraction is also that is the twinkling of stars. The last point, let me write it. Okay, the stars twinkles in the clear night. Stars also twinkles due to the refraction of light. Okay. The stars appeared twinkle on a clear night. Okay. So these are the same, you can say effects of refraction. Okay, or you can say it can be like examples. So the thing that I was saying like this, just a second. You can see that pencil is not actually straight, it's a little bit bended. You will, can you see this thing, yes or no?
Yes, sir.
Okay, any doubt so far?
So how's the twinkling of star an example?
Yes, Nibila, you are saying something, twinkling of star.
Yeah, how is that a refraction?
Yes, that is due to the atmospheric refraction. When we will study, you can say the chapter that is human light. Okay, so in that chapter, we will be studying atmospheric refraction. That is the cause of the twinkling of star. Basically, it is refraction, but actually it is happening in atmospheric layer. So that's why it is called atmospheric refraction. So due to the constantly changing, you can say, what I was saying, constantly changing densities of the different layers. So that that's why the twinkling happens. Okay, we will study this in the atmospheric refraction part. Okay, don't worry. Actually, this is atmospheric refraction, so it is happening in the atmosphere. That's why it is called atmospheric refraction. Okay.
Okay.
Yeah. Okay. So, okay. So just a second. Okay. So let me take some questions. Okay, before starting any other topic. Okay, now tell me this answer. Okay, Harshit. What about you, Nabila and Gianna? What one answer by Nabila? What about you, Gianna?
Sir,
Yes, Nabila. Yes,
so
Anand.
the
Yes.
so is refracted away from the normal.
Refracted away from normal. Yes, it is clear. So be option, right? Basically. So yes, it is B option. Just a second. There's my pen. Yes, option B is correct. So basically, when the light goes from denser to rarer, it basically goes away from the normal. Okay. Any doubt to anybody? Please tell me.
So what is the option correct?
B option, which is B option. You were right.
Oh,
Yeah.
okay, I'm right.
Okay.
I'm right, sir.
Any doubt so far?
No, sir.
Sure.
Mm,
Chalo, ठीक है. So let's understand one topic that is called lateral displacement. That it happens basically when air goes from basically the light ray goes from air to glass and then glass to air. Okay. So let's understand this thing, lateral displacement. So lateral displacement, and let's understand this with the help of diagram. Then we will do the you can say the definition part. Okay. So this is the. So first of all, light ray is incidenting like this. Okay. So again, so if this is a media, so normal will be here. Yes or no, बच्चों?
yes, sir.
ठीक है. So it will be like this. Okay. So now this is air. This is air. This is glass. Okay. So I'm basically marking at it as glass. Okay. As glass. And this is again air. Okay. This part is air. Okay. Like this. Clear? So, so what will happen when the light goes from rarer to denser? It will refract towards the normal. Yes or no, बच्चों? Please tell me,
Yes.
Harshit, Gianna, and Namila. It will refract towards the normal.
Yes.
Okay. So again, you can see this thing. This is an incident ray for this for this boundary. Yes or no? This is a refracted ray for this boundary, but this boundary, this light is striking this boundary, so
Yes,
this will become incident ray for this boundary. Yes or no, बच्चों?
yes, sir.
ठीक है. So now you can see this thing. Now the boundary is going. So basically, now now you can see the ray is going from denser to rarer. So what will happen? What will be these? You can say where it will go away from normal or towards the normal.
Should be away.
Away by Nabila. What about you, Gianna and Harshit?
So see
Yes,
now.
बच्चों. Harshit, Gianna.
Sir,
What about you, Harshit? बोलो बच्चे. Your voice is cracking.
Sir, I'm saying, could you please repeat the question?
I'm saying that please. I'm saying that where it will go. Will it will it go away from the normal or towards the normal?
Sir, away.
Okay, Gianna, आप बताओ.
So away.
Away, yes, because it is going from denser to rarer, so it will go away from the normal. Okay, so like this. Just a second. Away from the normal. So it will be like this. Just a moment. So, but what will happen is that this line is supposed to follow this path, yes or no? Straight without refraction, but due to the change in speed of light, it will follow the path. It will change its path, yes or no? And this line should have followed this path, yes or no?
Yes,
Harshit, Gianna, Nabila, clear बच्चों?
yes, sir.
ठीक है. Okay. Just a second. So you can see this thing that these two rays, if I extend these rays, if I imagine this thing, that these two rays are actually parallel to each other. This ray, incident ray, and the emergent ray. Emergent ray means the ray which is basically getting out from the medium. Okay.
Okay, sir.
This is the incident ray. If I extend this line, this will be incident ray, yes or no?
Yes, sir.
Clear है?
Yes, sir.
ठीक है. So this is called lateral displacement. Lateral displacement means when the light ray strike the rectangular glass block or slab, it will emerge out parallelly to the incident ray. Okay, it will displace. This distance between these two rays is called lateral displacement. This distance is called lateral displacement. Clear, bachcho? Please tell me, is this clear or not?
Yes, sir.
Okay, so this is
Only
incident ray.
possible for three case, like rarer, denser, rarer.
Basically it should basically it's we are assuming this for glass because this is a, you can say, definite shape thing, na? So that's why. Okay.
Okay, sir.
Yeah. So it is incident ray. Okay, this is incident ray. This will be refracted ray. This will be refracted. This is angle of, this is what? This is angle of incidence, angle made by the incident ray, and the normal is called angle of incidence. And this will be your angle of refraction. So as you can see this thing, angle of refraction, this angle of refraction. So due to the alternate pair of angle, you can see this thing. This is these are parallel lines. Normal are parallel to each other, and this is a transversal. So this will also be same. Yes or no, बच्चों?
Yes, sir.
ठीक है?
Yes, sir.
And this way, this angle will be called as emergent angle, angle of emergence. So by this, so if the rays are parallel, so you will, angle of incidence will be equals to angle of emergence. ठीक है? Clear है?
Yes, sir.
Yeah, please wait for a moment. Actually, Azan right now. Just wait for a moment, bachcho.
Okay, sir.
Thank you. Okay, Bachchan, so let's continue. Okay. So let me write down the lateral displacement definition. The perpendicular distance the perpendicular distance between original path incident ray and ray coming the glass slab is called lateral displacement. Is this clear, Bachu? Please tell me any doubt so far to you.
So a glass slab means this won't work in any other kind of glass.
Your voice is lagging a little bit, Navita. Please speak it again, dear.
So is this possible in a glass cup?
No, it should be rectangular.
Mm.
Okay.
Okay.
Okay. Please let me know if you have written it down.
Yes, sir.
What happened if the incident ray is not obliquely incidented, but actually it is basically parallel to the normal? Suppose this is a glass slab, okay? Just a second, let me. Yes. Okay. So this is the glass slab, and so your incident ray is perpendicular, is incidenting perpendicularly. So and this one is normal. So normal and incident ray are coincident to each other right now in this case, which yes or no? Okay. So now tell me what will be the you can say path of this ray.
Straight.
Okay, Nabila said straight. What about you, rest of you, Gianna and Harshit?
I'm straight. Sorry, sir, straight.
Straight. What about you, Gianna?
So straight.
Straight. Yeah. So basically, when the light ray incident parallel normally to the glass slab, there will not be any refraction. It will go straight as it is. Okay. Like this. It will go
Okay, sir.
as it is. Okay. The light ray will not, you can say, refract at any point. Okay. So I'm writing it here. Just a moment. Yeah. Ray falls normally to the surface of a glass slab. Okay. Then there is no bending of ray. ठीक है बच्चों, clear है?
Yes, sir.
As it goes straight. Any doubt so far to you, bachcho? Please tell me.
No, sir.
Yes, sir.
Sure.
Yes, sir.
Okay. So this is the case when the refraction happens to a glass slab. Okay.
Okay, sir.
Chalo, just a moment. Let me give you one question. This, tell me the answer for this question. ठीक है, ठीक है अर्षद.
Sir, I don't know.
Okay, Nabila. Gianna, what's your answer?
So, but I'm guessing C.
ठीक है जियाना. अच्छा क्या नबीला. जियाना आप बताओ.
So 90.
90. Yes, it is 90. Okay. So why 90? You can see the ray of light passing from medium 1x to another. Okay. And no refraction occurs if the light ray hits the boundary of medium y. Okay. So the angle of angle would be 90. I've told you just in the previous case. You can say it is, suppose this is x medium and this is y medium. So at the boundary of y medium, there is no refraction because it is striking perpendicularly. Okay. Please tell
Okay,
me if
sir.
this is clear to you or not.
Yes, sir. Yes, that's clear.
Okay, just a moment. I have one more question. Now tell me this one. I have one more question in front of you. I got one answer from Harshit. Harshit said, okay, Harshit.
Yes, sir.
Okay, okay, no, I was just saying that you told me the answer. What about rest of you, Bachchan, Nabila and Gianna?
So for the 36th question, right?
Yes, yes, yes.
So D.
Sheikh Nabila and Gianna. Yes, it is D. So why? Can anybody tell me the reason why it is D, not
It's
A?
going from denser to rarer.
Denser to rare. Yes, obviously, very good. Yes, Harshit. Yes, Harshit, very good. So basically, the light ray is going from denser to rarer medium. So basically, glass is more denser than water, right?
Yes, sir.
So that's why it is going away from the normal. It is refracted away from the normal. Clear? है? अच्छा, ये वाला, please let me know the next one. This is a very good question. Analyze this and let me know the answer.
So
Yes, yes, Jana.
is it E?
Okay, you said E. Okay, we will verify. Please draw this diagram. Draw the diagram, bache. If without drawing, you won't be able to answer correctly. Draw at least what I'm saying.
So D.
Okay. Nabila said D. Just a second. I got one answer in the chat. It's Harshit said C. Acha, so Gianna said E, right? Gianna, you said E, Namache?
Yes, sir.
Okay, check. Check. Gianna is saying E. This is for Gianna. Harshit said this. And Nabila, you said D, Namache?
Yes, sir.
Check. This is Nabila. Okay, so let's understand this thing and analyze first. Check. So water is denser or air is denser? Please tell me which one is denser?
Of water.
Water.
Water is denser. Okay. And so you can see this thing ray is coming from water and it is emerging out in air. So it will go away from the normal or towards the normal? Bolo?
It would be away.
It should be away. So in this first first figure, what it is showing, is it showing away from the normal or towards the normal?
Towards.
Towards the normal. It means that first is not clearly first you can say figure is not clear, you can say correct.
Yes.
Okay. In doubt so far?
No, sir.
Okay. That means that first option is not correct. Second option, light ray is coming from air and it is emerging, it's going into the you can say glass. So is it denser or air is denser? Which one is denser?
Glass is denser.
Huh?
Glass is denser.
Glass is denser, so it will go away from the normal or towards the normal?
It would go away.
Glass is denser, so it will go away or towards? Gianna, Harshit, and Nabila.
Sir, away.
I'm asking, will it go away from the normal or towards the normal? I'm not saying it what it is showing. I'm asking, will it go away from the normal or towards the normal? Just answer me, away or not, away or towards.
Away, sir.
ठीक है, हर्षित said away. जियाना आप बताओ. Gianna, are you there?
Oh, yes, sir. Sir, can you hear me?
Yes, yes, I can hear you. I'm saying that what will it go? It will go away from the normal or towards the normal?
Sir, away.
ठीक है. Okay. So away from the normal by Gianna. Nabila, आप बताओ, will it go away from the normal or towards the normal?
Towards.
Towards. Yes, it will go towards the normal. Why are you saying air is denser or rarer?
Sir, rare.
Rarer, na? So, and if you are going from rare to denser, what it would be? Towards the normal or away from the normal?
Oh, sir, okay, sir. Denser it's towards. Okay, sir.
ठीक है?
Okay, yes.
So it is also wrong. And next one, glass and water. Which one is denser?
Water.
Glass is denser.
Glass.
No, sir, water. Water.
What? Which one is denser? बच्चों, at least answer to me. Glass or water? हर्षित आप बताओ चलो पहले.
Water, sir.
ठीक है, water. आप बताओ now. Gianna, it's your turn.
So, water.
Water. What about you, Nabila?
So glass is denser.
Glass is denser. Obviously, glass is denser. अभी हमने last question में किया है बच्चों. Glass is traveling from water, enters into the water. It is refracted away from the normal. All of you gave me the answer. Now you got confused. Hello? Now you're getting confused even after giving me the right answer in the same previous question.
Yes, sir.
So what it would be? Will it go away from the normal or towards the normal?
Sir, away.
Okay. So what will be the, so what image is basically is here in the question?
Towards the normal.
Towards the normal. Is it correct or wrong?
It's wrong.
Yes, it is wrong. So that's why. So this question, that's why I've given you this question, because you got confused and like you were giving me the answer. Just I want to check whether you are giving me the same answer in this question or not. So this is also wrong. Okay, because glass is denser and water is rarer, so it will go away from the normal, not towards the normal. Now let's come to into this picture. Glass is, you can say, glass light ray is coming from glass into the air. What will be the you can say, it will go towards the normal or away from the normal? Which one is denser? पहले ये बताओ आप.
But denser to rarer is away from the normal.
Denser to rarer,
Sorry.
away from the normal. Okay, by the
Yeah.
Nabila. ठीक है. What about you, Harshit and Gianna?
So it is glass is just denser.
So where it will go, towards the normal or away from the normal?
So away.
Away. Okay, Gianna, आप बताओ.
Yes, so away from the normal.
Away from the normal, yes. Obviously away from the normal, because glass is denser, air is rarer. So denser to rarer, it means that it will go away from the normal. So this is also wrong. So the only option left is this, because you can see this thing, water is rarer with respect to glass. And if it's going from rarer to denser, so it is going towards the normal. Okay. So towards the normal, this is only correct. So who gave the option E as the answer? I think it's Gianna. Right?
Yes, sir.
Yes or no?
Yes, sir.
Yeah, it's yeah, very good. Okay, so I hope this is clear to you. अब बताओ आप लोगों को clear है या नहीं है?
Sir,
Very clear.
एक doubt.
हाँ हर्षित बताओ बताओ.
Sir, water denser होगा ना glass से, so how could be glass denser?
अभी हर्षित अभी हमने यही तो किया है. Water is less denser. Water is not denser, dear, with respect to glass. Glass is denser. Which one is solid, Harshit? ये बताओ, which one is solid? Glass or water? So glass is solid. So which one will be more denser, glass or water? Which particles are more packed, like tightly packed?
Sir, solid glass.
Solid के होंगे, तो glass denser हुआ ना?
Okay.
Okay, clear है?
Okay. Yes, sir. Now.
हाँ, तो इसमें थोड़ा सा आपको डाउट होगा, but when you will do the denser rarer part, so if water is denser with respect to air, okay, so this is R. Air is rarer with respect to glass. This is denser. Glass is denser with respect to water. Glass is denser with respect to air. Water is rarer with respect to glass. Clear है?
Yes.
So that is also important to understand which one is rarer, which one is denser. Because if you don't understand this thing, if you don't analyze this thing, you will not get the correct answer. बताओ clear है या नहीं बच्चों?
Yes, sir. Now.
Clear, sir.
Any doubt so far?
No, sir.
ठीक है. Last question of this class would be like this. Okay. So I'm pasting one more question. Tell me the answer. I got the answer from Harshit. ठीक है.
So I
Jiana.
have sent the answer.
Yes, you said something.
So I've sent the answer.
Okay, Nabila. ठीक है, B, C, C, C. Okay. So a light ray is traveling in water, falls at right angle to the boundary of the glass block. The ray of light is refracted towards the normal, is refracted away from the normal, does not refracted, it is reflected along the same path. So Gianna and Nabila gave me the answer as C. Right? Am I right?
Yes, sir.
Okay. And Harshit gave me the answer as B. So Harshit, here I've told you right now that whenever the light ray falls on the right angle, falls at right angle to the boundary of any object, it isn't saying that only glass block of any object. Refraction will not happen. It will go straight. This does not refract. Clear?
Okay, sir. Actually, I didn't like मैंने वो right angle word नहीं देखा.
That is very important, Bachi. This is why it is very important. Okay, so this why this right angle word is very important for this. Okay.
Okay, sir.
Any doubts so far to you, Bachu? Please tell me. Arshit, Gianna, Arya, or Nabila.
No doubt, sir.
Sure.
Yes.
Chalo, okay.
Mm.
So, okay, so that's all for this class. In the next class, Bachu, we will understand the laws of refraction. And along with that, we will do that how what is the relationship between the speed of light and the speed of medium, and we will do and we will understand the refractive index. What is refractive index basically? Okay. So in the next class, we will do that thing. Okay. And I'm requesting you to please attend all the classes because these classes are very important. Okay. So I
Okay.
hope that everything is clear to you, Bachu, Nabila, Harshit, and Gianna.
Yes, sir.
Yes, sir.
That's good. Okay, that's good. So that's all for this class, Bachu. Good.